Welcome to the second session of the third module. In the previous class, in the session, we have discussed the various parts of the IC engines, and we have also discussed the classifications of IC engines and what are basically an IC engine means. This is what we have discussed, and we have also discussed a few of the terminologies which are compression, the clearance volume, the swept volume, the bore, stroke, TDC, that is the top dead center, bottom dead center, and we have also discussed the compression ratio. Okay, now in this session let us go in particularly two-stroke and four-stroke engines of petrol. Basically this sketch shows a clear picture of about the two-stroke petrol engine. Now first of all, I have told you it is nothing, stroke is nothing but a vertical distance between the vertical distance that is being moved or displaced by the piston moving from TDC to BDC, or maybe from BDC to the TDC. From TDC to the BDC and BDC to the TDC becomes one stroke. TDC from top dead center, it will come to the bottom dead center, and then it will go back to the top dead center. So this becomes one stroke. Is it clear? So in two-stroke petrol engines, as the name itself indicates, it will have a two strokes. Is it only two strokes? No, it means that the power which will be generated in the engines will take two strokes to generate the power. That is what we call it as a two-stroke engine. If it takes more stroke, four strokes, from TDC to BDC one stroke, from BDC to TDC second stroke, from TDC to BDC third stroke, and from BDC to the TDC, becomes four strokes. If it takes four strokes in order to generate the power, then we call it as the four strokes. Two strokes means from TDC to BDC, from BDC to the TDC. Is that clear? Now here what happens, since it is a petrol engine, as you can clearly make it out, there is a spark plug. Obviously whenever I talk about the petrol engine, it should have the spark plug, then there is a cylinder, and if you can observe one thing, two-stroke petrol engine, two-stroke engines and four-stroke engines have got its own different design aspects. So the designing of the cylinders in the four-stroke engines is entirely different than the design of the model of the engine in the two-stroke engines. Now in this two-stroke engines, we have got a piston size is much bigger, and if you see the top piston head, it is something like a curve. It is a wavy shape. Okay, now this thing will not be there in the four-stroke engines. We have a piston, the piston size is very bigger, and we have got three port, not valve. Please keep it in mind, they are not the valves, they are the ports. We have an inlet port, we have an exhaust port, and also we have the transfer port. Three ports are there: inlet port, exhaust port, and transfer port. Three ports are there in the two-stroke engines. Now there is a crankcase, crankshaft, and connecting rod. These are all the normal it's a common elements or common parts of any engines. Now if you can see this here carefully, through the inlet port, please observe the arrow marks which has been given. Through the inlet port, what happens is the fresh petrol and air mixture, only in the petrol engine I am talking about. In the petrol and through the inlet port, what happens? The mixture of petrol and air with the air fuel ratio. Okay, the petrol and air will get mixes up. The petrol and air will get mixes up, and thus it forms as a charge. So this fresh charge, that is what we call it as a fresh charge. Thus formed a fresh charge will enters into an inlet port. The mixing of this petrol as well as the air will also comes with a particular air fuel ratio. With this proper air fuel ratio, the charge which is being termed as a charge will enter into the inlet port of the cylinder. Then it enters into the, it will not enter into the cylinder, it will enter initially into the crankcase. Please see it carefully. The arrow marks which are all showing at the downward movement. That means the petrol and the air mixture, that is the charge, is entering into the crankcase instead of entering into the piston. The cylinder. Instead of entering into the cylinder, it will enter into the crankcase. From the crankcase, there is a one left side. What you can see, it is a perpendicular line or a tube-like structure, which you call it as a transfer port. Through the transfer port, what happens? This charge which has been entered into the crankcase will be sent towards the upper portion or the above the piston. Okay. Now what happens? Not the fresh charge is not entering into the engine cylinder through the inlet port. It is fresh charge is entering into the crankcase through the inlet port. Later it will enter into the cylinder using a transfer port. Thus what happens? So after that what happens? The piston will start moving downwards. As the piston is moving downwards, the fresh charge will enter into the top of the engine cylinder. Thus the exhaust port will be closed. Is it clear? So when it is coming downwards, what happens? The inlet port will be closed, so that it will open the transfer port as well as the exhaust port. Through the exhaust port, what happens? Already burnt gases, already burnt or combustible gases will escape out. The smoke will go out through the exhaust port, which is being placed just above the inlet port. Meanwhile, see, for example, now this is an exhaust port. My right hand is an exhaust port. Now this is a transfer port. What is happening? Through the transfer port, the main fresh charge, petrol and air mixture, is entering into the cylinder. Now this is an exhaust port where the fluid gases, the waste gases or the smoke which is going out, and this is coming in. This is coming in. What is? The petrol and air mixture is coming in, and the exhaust gases are going out here like this. So it takes place simultaneously. This is a very important point. I will ask you people to remember once again when I talk about the difference between 2-stroke and 4-stroke engines. Simultaneously, the exhaust gases will be going out and the fresh charges will be coming inside the engine. Then what happens? It comes down, as you can see it in the figure 2. It just comes down, and then what happens? It will go up. The piston will start moving upwards as the crank shaft makes half revolution, and then for the further half revolution, the piston will start moving upwards. At the end of the stroke, what happens? The petrol and air mixture which is present in the cylinder will be compressed to a very high pressure and temperature. We are compressing this petrol and air mixture to a very high pressure and temperature. At that compressed very high pressure and temperature, a spark plug will ignite a spark. A spark plug will ignite a spark at the end of this. So that what happens? It is already with a higher pressure and temperature. If you ignite a spark, what happens? Sudden combustion will take place. This rapid combustion makes the piston to go downwards and upwards. Makes these pistons to move up and down. That is, a reciprocating motion will be caused. Thus makes the crankshaft to rotate. So this is a cyclic process. Is it clear? So here in this, actually below the inlet port, I have mentioned it as a air fuel mixture. Actually this air fuel mixture is nothing but a petrol and air mixture, and this is also called as a fresh charge, or what we call it as a charge, which enters into the crankcase. Is it clear, man? Now, one of the major drawback over here in this is, as I have already told you to remember, the exhaust gases will be going out simultaneously as the fresh charge is entering. The fresh charge is entering and the exhaust gases are going out. It is going out and this is coming in. So what happens here? There are chances of mixing this fresh charge with a smoke. Whenever you burn something, what do you get? You will get a smoke. So if it mixes with the fresh charge, the efficiency reduces. the efficiency will reduce. That is a major drawback of this two-stroke engines. Is that clear? Now, the major components. Obviously, whenever I say it is a petrol engine, whether it is a two-stroke or four-stroke, spark plug is mandatory. It should be there. Is that clear? So soon after that, a piston will be there. A spark plug is a device. A spark plug is a device which is used to generate the spark within the cylinder. The spark introduced is used to burn the fuel in the cylinders. Okay. Now the piston. Piston is a reciprocating part of the engine. It is used for the suction and compression of the fuel within the cylinders. What do you mean by the cylinder? Cylinder, it is that part of the two-stroke engine which holds a piston within it. So within the cylinder, the piston will be there. The inlet and exhaust ports are present in the cylinder. The cylinder head consists of the combustion chamber and the spark plug. The transfer port, there are three ports once again. The transfer port is an important port wherein which it is used to transfer the compressed fuel from the crankcase to the cylinder. This is what I have told you. The fuel or the charge, petrol and air mixture, will enter into the engine cylinder not by inlet port. It is by the transfer port. Is that clear? So, next one is the connecting rod. It connects the piston and crankshaft. It connects the piston and crankshaft. It transfers the power from the piston to the crankshaft. That is the use of connecting rod. This is what we have already discussed in the parts of the IC engines. Then we have a crankcase. It acts, the crankcase is something a dome-like structure. That is what been shown in the previous figure. The crankcase, it acts as the base of engine. It supports the crankshaft and camshaft in suitable bearings and provides the arms for supporting the engine on the frame. The crankshaft is the part of the engine which is used to convert, the reciprocating motion of the engine into rotating motion with the help of the connecting rod. That is the use of this crankshaft. That is, ultimately we are just converting the nature of the motion. The reciprocating motion will be converted into the rotary motion. Is it clear? Reciprocating motion will be converted into rotary motion using a crankshaft. Exhaust port and inlet port. Exhaust port is the one through which the burnt gases or the smoke will be sent out of the engine cylinder, whereas the inlet port through which the fluid will be taken inside the crankcase, not in the engine cylinder. Next one is the balancing weight. Balancing weight is always made in the engine in order to have a mechanical balancing. Is that clear? Mechanical balancing, and there should be a counterweight so that we can avoid the vibrations. The two strokes of the engine are described as follows. In the upward stroke, what happens, and then in downward stroke, what happens? I just shall tell you. During the upward stroke, the piston moves from bottom dead center to the top dead center and compresses the charge. That is, charge is nothing but air fuel mixture. When it is moving from bottom dead center to the top dead center, it compresses the fuel and air mixture which is present in the engine cylinder. Okay. Now, because of the upward movement of the piston, the partial vacuum is being created. Since it is moving upwards, what happens? It creates a suction. It creates a section or a vacuum that makes the fresh charge to enter into the engine cylinder. Is that clear? So the crankcase, and this allows the entry of fresh charge into the crankcase through the uncovered inlet port. Now, one more important thing is ports are something like a passage, that's it. There is nothing called as a doors. Valves are different. Valves, what happens, if you want you can close it, if you want you can open it. They are something like a doors. Ports are something like a sliding window. They are just like a sliding window. Whenever the piston moves, it will closes. Whenever the piston moves this side, it opens. That's it. Are you getting my point? Ports are something like a sliding windows, whereas the valves are something like a wooden closing and opening windows. Is that clear? Now the exhaust port and the inlet port remain covered with the piston at the TDC. At the top dead center, what happens? This piston, as I just will show you. Now here in the second figure, or even in the first figure, what happens is the exhaust port and inlet port will be closed. Is it clear? At the while coming back. Is it clear? So while going upwards, what happens? These both ports will be closed. Only the fresh charge will be compressed. Is it clear? The ignition of the fresh charge takes place by the spark plug. What happens when the piston moves at the top dead center, near to the top dead center, the fresh charge will be burnt, will be compressed to a very high pressure. At this pressure and temperature, what happens? Spark plug will ignite just a spark, so that what happens? It just makes a burning. So the spark plug will be something like this, something like this. It will be seen on the top head, but still the spark, which will be, the tip will be exposed in the engine cylinder, so that the spark which has been ignited should make it to burn, isn't it? A spark is something like what the lighters that we use it for conventional gas stoves. Gas stoves, you might have seen it. A small spark is enough to initiate the combustion, isn't it? Next one is a downward stroke. As soon as the combustion of the fresh charge takes place, a large amount of the hot gases is produced, which exerts a very high pressure force on the top of the piston. That means on the top of the piston, what happens? Due to the rapid combustion, it exerts a force onto this. It exerts a vertical thrust onto this because of the very high pressure. Due to this high pressure or force, what happens? The piston moves downwards. The piston moves downwards and rotates the crankshaft. And does useful work. During this stroke, what happens? The inlet port is being covered by the piston and the new charge is compressed in the crankcase. So this is simultaneously. When it at the end of the compression stroke, or the end of this compression stroke, the combustion will take place and it exerts its thrust and it just comes down. And once again, while coming down, what is happening is the fresh charge is entering into the engine cylinder and exhaust gases are going. After this, piston will start moving upwards. When it is moving upwards, what happens? Transfer port is closed and the exit port is closed. Only the inlet port will be open. Due to the vacuum pressure, it enters in. So this is a cyclic process. During this stroke, the inlet port is covered by the piston and the new charge is compressed in the crankcase. Further downward movement of the piston uncovers the exhaust port and the transfer port, and exhaust starts through the exhaust port. That is, the smoke will start expelling out of the cylinder through the exhaust port. As soon as the transfer port opens, the charge through it is forced into the cylinder. The charge strikes the deflector and the piston crown rises to the top of the cylinder and pushes out most of the exhaust gases. The piston is now at the bottom dead center position. This cylinder is completely filled with the fresh charge, but it is somewhat diluted with the exhaust gases. That is what I have been telling you. There are chances wherein which the fresh charge is dilute, will mix up with the waste gases or the exhaust gases. Finally, the cycle event is then repeated. We get 2 strokes for a single revolution of the crankshaft. That means the power will be generated by the 2 strokes of the piston and 1 revolution of the crankshaft. That is working principle and construction features of the two-stroke petrol engine. Now the same one, let us talk about the four-stroke engines. What are the four strokes? Basically these four strokes are being classified like this. First one is a suction stroke, second one is a compression stroke, and the third one is the working stroke or a power stroke or an expansion stroke, or we also call it as an actual stroke. Then we will go for exhaust stroke or exit stroke. Is it clear? Now let us go one by one. Cycle of operation completed in four stroke of the piston are two revolutions of the piston. Now what happens? The crank will make completely one revolution in two strokes. Two strokes ಅಲ್ಲಿ ಒಂದು crank ಒಂದು revolution ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ four strokes ಅಲ್ಲಿ obviously it makes two revolutions. Is it clear? No, they are all. The first one is a suction stroke. Suction valve opens and exhaust valve closed. Charge consisting of the fresh air mixed with the fuel is drawn into the cylinder due to the vacuum pressure created by the movement of the piston from TDC to the BDC. This is first stroke. In the second stroke, what happens? In the compression stroke, both valves are closed. Fresh charge is compressed into the clearance volume by the return stroke of the piston and ignited by the spark for the combustion. Hence, pressure and temperature is increased due to the combustion of the fuel. This is what we call it as compression stroke. Then the third one, few people call it as an expansion stroke, or few people also call it as a working stroke. Few people also call it as the actual stroke, and it is also called as a power stroke. So there you can call it as different ways: expansion, actual, combustion, or it may be power stroke, or it is also called as an actual stroke. So there are different names for this because it is the one stroke during which actual power is being generated. Is it clear? Now, if you consider the expansion stroke, in which what happens, the both valves are closed and the high pressure of the burnt gases with the three strokes, this here piston towards this force makes it to move towards BDC to the towards BDC from the TDC, and hence the power is obtained in the crankshaft. Is it clear? So the exhaust stroke, in the exhaust stroke what happens? Only the exhaust valve is open and the suction valve is closed. Burnt gases expel outside due to the movement of the piston from BDC to the TDC. Now here I shall show you with a different one. Now here please observe the figures one by one from left moving towards to the right. In the first figure, the air and the fuel mixture, I just always tell you 4 points for each figure. 4 points for each figure. It makes you easy. IB stands for, basically IB stands for inlet valve, EV for exit valve or exhaust valve, EC is nothing but engine cylinder, and CR nothing but connecting rod, C for the crank, and SP for the spark plug. Now here, please be careful here. The piston is indicated with two parallel lines. Basically, four-stroke engine takes place in four different strokes. One is a suction stroke, first figure. Second, compression stroke, second figure. Third one, working stroke, third figure. And exhaust stroke, that is the fourth figure. Now, for each figure or each stroke, I will give you 4 points. If you can remember, that is more than sufficient. So what happens in the suction stroke? In the suction stroke, in the suction stroke, the inlet valve will be open and the outlet valve will be closed. Outlet valve is nothing but exhaust valve. It is the same thing. The inlet valve is open and the outlet valve is closed. First point. Second point. The piston moves from top dead center to the bottom dead center. Piston moves from top dead center to the bottom dead center, due to which there creates a vacuum or a partial partial vacuum or create a suction. This is the second point. Okay, first point is inlet valve is open and outlet valve is closed, and then second point, the piston moves from TDC to the BDC, which creates a partial vacuum or a suction pressure inside the engine cylinder. Third point, the fresh air and fuel mixture, that is a fresh charge, will enter into the engine cylinder due to the partial pressures. Okay, this is the third point. Fourth point is the connecting rod or the crankshaft makes half revolution. As you can see it here, it makes a half revolution. My dear friends, it is very easy to remember because the arrow marks I am just showing it downwards. The movement of the piston, it is showing downwards. Is that okay? No, I just tell come again once again. Inlet valve is open, outlet valve is closed, and then piston moves from TDC to the BDC, which creates a partial vacuum so that the fresh air fuel mixture will enter into the engine cylinder. Third point, what happens? The fresh air and fuel mixture will enter into the engine cylinder. And the fourth point is the crankshaft makes a half revolution due to the movement of piston from TDC to the BDC. Is it clear? That's it. So that 4 points is nothing but a suction stroke. In the second one is a compression stroke. In the compression stroke, both inlet valve and outlet valve are closed. So what happens? Piston moves from bottom dead center to the top dead center. Second point. Third point, the fresh charge, that is the petrol and air mixture inside the engine cylinder, will be compressed to a very high pressure and temperature. Is it clear? So the fourth point, the crankshaft makes, or the crank makes half revolution. Is it clear? So that what happens in the suction stroke, half revolution; in the compression stroke, it is half revolution. This is the 4.601. Next, the working stroke or a power stroke or an actual stroke or a combustion stroke. If you can remember, you should remember it as a combustion stroke or a power stroke, according to me. Why I will tell you. First point, in the working stroke, in the power stroke, what happens? Both the inlet and outlet valve will be closed, and the TDC, and second point, the highly compressed, that is a air fuel mixture with a very high pressure and temperature will be ignited, will be burnt by igniting a spark from the spark plug. This is second point. So what happens? The fuel and air mixture, which is at a higher temperature and pressure, will be ignited using a spark plug. So the combustion does takes place. Third point, the combustion which takes place, which is so rapid that it exerts a thrust onto the piston head. This is third point. Fourth point, here also the crank makes half revolution. Is that clear? And actual work in the 4 strokes will be always generated in the third stroke of the system. Is that clear? See, this is the 4 points. Now the exhaust stroke. This is once again 4 points. The inlet valve is closed and the outlet valve is open. Inlet valve is closed and the outlet valve is open. First point. Second point, the piston moves from bottom dead center to the top dead center. From bottom to the top it moves it. So that what happens? The waste gases or the smoke is expelled out through the exhaust port or outlet port. Third point. Fourth point, obviously, once again the crankshaft makes half revolution. Now you can tell me, my dear friends, what is the total number of revolutions that a crank has been made? It is half in suction stroke, half in compression, half in combustion, and then half in exhaust stroke. So completely half plus half plus half plus. So it makes 2 complete revolutions. That is the beauty of this 4-stroke petrol engines. Did you understand? The same way, for each and every stroke, you just write it as a bullet points in 4 lines. That's sufficient enough. Okay, now this is what we have given it here actually. The travel of the piston from one dead center to the other dead center is called as a piston stroke, suction stroke, compression, power or an expansion stroke, and exhaust stroke. As usual, we have just given the same thing. In this stroke, the suction valve opens and the exhaust valve remains closed condition. The piston moves from top dead center to the bottom dead center, that is from the TDC to the BDC, and then the charge, that is the air plus fuel, enters the engine cylinder due to the partial vacuum developed inside the cylinder when the piston reaches BDC and the inlet valve closes and the flywheel makes a half revolution. Flywheel, or you can say it as same thing as we just explained you. Few people say that at the end of the compression stroke, the spark plug gives out a spark, or nothing but the beginning of the working stroke also it holds good. Is it clear? Now then the power stroke, in which the actual power will be generated, and in the exhaust stroke what happens? The smoke that is being produced by the combustion will be expelled out in the exhaust port or in the outlet port.